Welcome to Level C Math Week 9. I've done a little bit of rearranging. I had put the PRISM stuff in Mad Science, but it really isn't just smashing things together. That whole idea of we're going to make a plan and we'll write out it's this shape plus this shape plus this shape plus this shape, and then change the plan into formulas and then change the formulas into numbers, then that's something that is more like an equation type thinking. So I just moved that stuff to justice where we're dealing with equations, but that's just an arrangement thing. There was also something with patterns that Ruthie decided to do as her presentation. And that was in the health formulas, just because long ago, when I was teaching a class that had the health formulas as an important part of it, then we wanted to start with patterns so people would know that formulas came out of patterns. But there's nothing about health decisions and patterns that really make them go together. So I put patterns at the end because that's sort of a good level C thing that you need. So I'm not going to hide it in health. So we didn't do all of patterns when we talked about patterns, but we've done enough. If you want to do more of these, you can. It is not a homework I'm going to try collecting or requiring of you, but if you want to challenge yourself, then the homework is ready. But if you want, you can think of that as a preview of level D, not something you have to do here in level C. Then the other rearranging I did was I spent a bunch of time since I've seen you last looking at the typicality. Again, a lot of this is more than level C, but we want to talk about the picturing data and the averages at least a little bit. You might go into more depth in level D, but for C, we should at least get you some small exposure to it. And we've done a bunch of this already. So where we will start today, if people don't have homework questions about equations, is by going back through the things about charts and bar graphs and stuff like that. Okay, any homework questions we want for any of the equation things or anything earlier?
I needed some help on the measurement.
Measurement, okay, which one?
I see, I wrote them down. Oh crap, hold on, I'm trying to find just wrote it down.
Okay.
Let's see, question 3.
3. Okay. I think I've drawn that one before. I remember that. So let me grab.
I can go look at it too. That's fine.
I know we've started it. I don't think we've finished it. So. Yeah, in fact, I'm quite sure we haven't finished it, but let me save time by grabbing where we drew it. So this was Tuesday of last week. We made the picture just because sometimes having the picture is nice, but we did not finish it. This little thing, by the way, I just might need that later. So I stuck it in the Jamboard to have it ready. Okay, so we have a square, the sides are 10 feet long. So maybe this is part of some playground game in an elementary school or something, pretty big square. And it has the top quarter removed, like a triangular bite that was taken out of the top. So what is the rest of the area? So how would we figure this out?
Find the area of the square first.
Okay, that certainly makes sense. So here is the whole square. Oops, let me write draw that better. Okay, now I've caught up to you. So how do I do that?
Length times width.
Length times width. So 10 times 10, it's 100. That's not bad. Okay, now I need to get rid of this part because that's like a cookie cutter came and took a bite out of my cookie dough, right? How do I do that?
I would divide it by 4.
Yeah, you could find the area of the triangle, but that's kind of a trap. You could say, how big was this cookie cutter area that I punched out with my cookie cutter and got rid of? And I will subtract that from 100. If you did that, great, but that is more work. The shortcut, thank you for mentioning that, is to say this square is actually 4 even pieces, and we have 3 of them. So let's just cut it into 4 and then have 3 of them. That's a lot faster than trying to do 1/2 base times height and subtracting and stuff. Questions about that one?
I'm good.
Good here, thank you.
Everyone happy with why there's 3 of them? 1, 2, 3.
Yeah.
Okay. Other homework questions from either this or someplace else in the Justice?
I had some under the percentages, the percent.
Which one?
5 and 6.
5 and 6. Okay, I'm going to change the numbers on these since I don't have things drawn already. Let's do, instead of an $8 tip, a $12 tip. Patrick is a big tipper today for some reason. Okay. So for percentages, we have 2 different ways to do this. What's the percent sentence that we are thinking of with the words what is of and percent?
What is $12 of 50?
So yeah, $12 I shouldn't have put what first, it's not always. So $12 is what percent? Sorry to be obtuse there, okay. So there were two ways to do this. You could do a translate way. Or you could do a proportion way. If you're doing the translate way, then you take each thing and translate it. So a number stays a number. And is becomes equals. What becomes our letter? Of becomes multiply. A number stays a number. And this looks like our familiar one-step equations. Something is attached to y with multiply. What's the opposite of times 50? That would be divided
Division.
by 50. And I'm almost done, because once I do that, .24. Oops, that's not almost equals, that really is equals. So the last thing is anytime you use the translate method, you have to have a riplop somewhere. Either you do it in the beginning because they give you a percent and you want to get rid of it, or like this at the end, you're going to go right into percent because they ask for a percent and you haven't paid for that yet. If you want to make something out of 100, you have to do the opposite first, otherwise it's not fair. Everyone okay with the left-hand side if you're a proportion problem? I'm sorry, a translate kind of person?
Yes.
Okay, if you're a proportion person, then you have the four parts of the proportion. So fraction bar equals fraction bar. Then this is your percent. This is 100. And that's part over whole. The part out of 100, that's the percent, and just the number 100 is going to go there. On the other side, the other situation in the proportion, we also have part over whole. And the secret to knowing which is which is that the whole always comes after the word of. And the part is the thing that's left over after everything else is filled in. So in this case, the percent I don't know. This is always just a 100. The thing after of is the 50. And the part, the one I haven't used yet, is 12. So 12 out of 50 is the same as y out of 100. Everybody okay with my setup?
Yeah.
And remember that I have paid for my percent with over 100 already. So when I get to the end, I don't need to do riplop. So then I cross multiply y times 50 on one side. I can keep drawing my swooshes if you need me to, but this is kind of crowded, so I am attempting to skip it. You can see this looks quite similar, but instead of a 12, I have a 1200. I've paid for my percent already. Things are 100 bigger. So I will get 24, and then I just shove a percent symbol on it because I paid for it already. Everyone who's a proportion kind of person, okay with the right-hand side?
Yeah.
Yeah.
So I'm expecting I've probably done too much since you have all been good at attending class and stuff. The hard part of these is usually setting it up. And what makes it hard is if you try and skip this. So go ahead and make the little Mad Libs thing. Blank is blank percent of blank. And then say, the 12 goes there, the what goes there, the 50 goes there. Once you turn the English paragraph into a percent sentence, then the rest is often, no one gets that wrong unless they make a careless mistake. So this is the stumbling block there. Don't skip that over. Skip over that. Okay, number 6 also. A project on Kickstarter was aiming to raise $15,000 for a precision coffee press. They ended up with 714 supporters and raised 567% of their goal. So 500% would be times what?
5.
Times 5. So a 15 is times 1, a 30 is times 2, a 45 is times 3, a 60 is times 4. So they've got about $75,000 just as an estimate before we get started. So we should get something bigger than that when we do this. Okay, so same thing, same setup going on here. Do you want me to arrange things differently so we have room for me to draw the cross multiplying swooshes?
Sure.
Sure, okay. So then I will put this a little lower and put translation and proportion method over here. Okay, now I'll have a little more room. So whichever way you do these, then this again is the part or original or the change. That's the percent. And that's the whole, the baseline for comparison, something like that. And for this one, we have the one that's left over, the part original or change. The one that's of something, the percent, and just the number 100. Everyone okay with my setup?
Yeah.
Okay. So what goes in my spots? What is the part in this case? Or maybe that's not the right question. Maybe we should start with one of these numbers is a distracting red herring that's just trying to confuse us. Which number can I ignore?
The 714.
714. It doesn't matter how many supporters they had. That's just a distraction. Okay, now I will ask, what's the part, the original, the change?
So would it be Y?
Y? No, we know what it is. And again, don't put a Y in this first step. Put a what, because we're not translating it yet. Maybe the percent is the easy one. What should we put in the percent?
567.
567. So is it what is 567% of 15,000? Or is it 15,000 is 567% of what?
$15,000 goes first.
If we did that, then their goal is more than 5 times as much of something. So that's not what's happening. They're about a whole lot more than their goal. So this is the thing that will become the y. But for now, let's just keep it a 1.
And then 15,000.
Yeah. So what is more than 5 times 15,000? That's the situation we have. Does that make sense now?
Yeah.
So when we translate it, we're going to do our riplop to get rid of the parentheses left out of percent. And we get what now is y equals 5.67 of becomes multiply 15,000. So y is just that. I just multiply. So 5.67 times 15,000 gives me 85,050 bucks.
Yeah, I just set it up completely wrong. I think the translation is the hardest thing for me to understand.
It is.
Solving it is easier than putting it into like a translating it.
That's one reason that the final doesn't change that much. There's sometimes a few versions of things, but
Thank you.
I can't randomly create translating situations. I wish I could. So for the proportion people, let's do this that way too. 567 is the percent. That's always 100. Is it okay that this fraction is bigger than 1?
Yes.
Yeah, it's bigger than 5 because we're making it bigger, right? Then the thing after of, that's the 15,000. And the thing we haven't used yet, that's the what, that's the y. So now y times 100 is 567 times 15,000. That's going to be 85,050 with 2 more zeros. And we have something stuck onto y with 100. So we'll do division. And get back where we want. Okay, all happy with number 6?
Yes.
I just realized I forgot to change the number. I just did your homework.
That's okay.
Okay, other questions?
Yeah, I got a lot wrong on this one.
That's why you get to turn it in more than once. No one expects you to be perfect.
Yeah, I can go ahead and try it again. I think I just need to read more into the notes and stuff. Oh.
Okay. Besides the 10 exercises for each topic, you should also now be starting these overviews and bring me questions on those. Has anyone actually done one of these already over the weekend and has a question from the overview test?
Should we be starting that even if we're still finishing up the rest of the 10 exercises?
I would. And
Okay.
let me do a quick talk about study skills, just in case no one has taught you this. Practice quizzes and tests. So you can read this later on your own, but what I want to do is this part. So has anyone ever learned either a Tai Chi form or some other martial art where everyone stands and copies the sequence of moves that the instructor does?
No.
No. Okay, picture that if you haven't. If I was to teach you how to do such a thing, then we would never really have the goal until the very end of the term. I have taken, by the way, a Tai Chi class at LCC. They have some very good Tai Chi instructors and some not so good. It's fun to do if you get a good one. But normally you're not trying to finish. There might be a sequence of 30 different movements you're trying to do. And if you're just learning them the first day of class, you're not going to remember 30 different things. So your instructor will try just a few problems. They'll say, here's the first movement. Let's all do this. And everyone does that movement. And you keep doing it 5 or 10 times. And then your instructor says, here's the second movement. Let's only do that one. And that's all you do 5 or 6 times. And then your instructor will say, let's try doing the first movement and go right into the second movement. So you go 1 and 2 and practice the 2 of them together 5 or 10 times. And then you add the third one and do just that. And then you do 1, 2, and 3 all together and so on like that. You don't try and do the whole thing at once. And when you get in the middle of the term, now it's week 5, maybe you will be learning movements 11, 12, and 13. And you'll just, again, practice 3 or 4 at a time because it's not the right thing to do for your brain to try and do 30 things all at once, again and again and again. So when you are doing a practice test, then your job isn't to sit down in one sitting and try and do 38 problems. That's not the right way to do this. So start by doing just a few of them. And if you get them right, great. Then say, this one is not a problem to me anymore. So now I will do 3 of them, maybe those 3, right? And then you say, okay, I think actually all of those are good. Now I'm going to try these 3. And then, oh, wait, I have a little more time today. I'm going to do all 6 just to make sure I'm still on top of that. And then you come back another time and say, let's do 7, 8, 9, and 10. I think I'm up to 4 of them at a time. And then, okay, 8 I got. I'm going to do 7, skip 8, and let's do 9, 10, and 11. And oh, now I have a lot of time. Let's see if I can do all 11 at once, and so on. But build up slowly. Does that make sense?
Yeah.
So
Yeah.
whether it is this week, because you are on top of things, or whether it's week 10, because your life is crazy and you're scrambling to keep up, whenever you start doing these, and I hope it's this week, that doesn't mean that you will even look at the bottom of the page. Do enough that you are getting good practice on what you need to do. It's not like you can learn 5 things at once anyway. Learn one thing at a time and reinforce the other things. That is your goal. But we have 3 weeks, right? Week 9, week 10, and finals week. So you have lots of time to practice these tasks until you get good at them.
For the overview, do we turn it in like we do for homework, or do we take a picture of what we written down and send it to you?
Normally neither. Since you get to see your answers, unlike the 10 exercises, then you don't turn that in,
Okay.
right? You just keep doing it till you're happy. Once you are able to do the whole page, then there are some achievements about it, right? There's the ones about taking a test. Can you get 70% on any one of them? Maybe just the shape-shifting one or just the mad science one. Can you get perfect on any of them? Many students never do. Can you get 70 on 2 of the topics? Because remember, each of these has their own thing at the bottom. And so on. So if you get 70 or more, and then lastly would be there's a 70 for an overview too. No, 66. So for the whole level C overview, can you get 66 or more? So if you do that, let me know and I'll check it off. And I will always know whenever you want a recommendation or job interview praise or things that, yes, you did great on one of these tests. If you're wondering, am I ready to move up to level D? Then this is a good goal. Can you get 66% or more on the level C overview? When I ask you to turn things in a written way, then it'll be a little stricter than that because that's 66% of all 38. So if I say turn in your best 34 and you can have 4 of them you skip, then I'll want you to do a little better. Okay, questions about any of that?
Not that I can think of.
Okay, let's look at typicality. If you weren't here last week, this will be a good review. Holler if I'm going too fast. I'm assuming that this is a review partly because we've done it last week and partly because most of these things are something you've seen before. So before we can really talk about what is typical, we have to be able to look at our data. So the beginning of typicality is how to picture data. And we had this somewhat annoying picture that a elementary school teacher drew where she asked 21 students what their favorite pet was. And this green girl with catfish, fish, bird, cat, that's like 5 students all put together in that yellow speech box. It's not like one student got to vote 5 times and so on. So that was not a helpful way to picture this data. It wins points for color, but not for ease of use or multiculturalism. It's better to make a frequency table. A frequency table has 2 columns. Here's all the categories, cat, fish, bird, so on. And then the frequency that each appears. So compared to the colorful picture, you can say, oh, there's 6 cats. I can see that right away. Oh, there's 3 fish. I can see that right away. Everyone okay so far?
Yeah.
Yeah.
Then I could take that chart and turn it sideways and color in colorful squares, however many the number was. And look, I've made a bar chart. It's a really ugly bar chart. Normally they look nicer like this one, but that's how we get bar charts. It's the same thing. It's the categories. And then the height is how many kids picked that animal. This bar chart doesn't have any particular order. I don't think it's on the GED, but there's a jargon, a Pareto chart is when you sort things, tallest to smallest. So maybe you need to know that, but maybe not. So far, that's just counting. To put a little more math, we can do percentage is part divided by whole and make another column. So now there's this relative frequency column. There were 6 cats and 21 total. So 6 divided by 21 is 29% for cats. Similarly, there were 3 fish. So we'd have to do 3 divided by 21 and we'd get 14% picked fish and so on. Does that make sense for everybody?
Yeah.
Yes.
So you could find the percent of all of them, and that's often a more useful number. So we'll get to some applications of that. There's a famous thing, Gretchen Rubin's 4 tendencies quiz based on a book she wrote. And so not me, a different math instructor had her class pick, do this for tendency quiz and see which they were, a questioner, rebel, obliger, or upholder. So here is the frequency. And with this one, we can complete the table. So first write everything as a fraction, put it over 22. Once you have a fraction, top divided by bottom gives you the decimal. Once you have a decimal, riplop gives you a percent. So could you fill in this chart if you needed to on homework?
Yep.
Anyone want me to actually write out and do all of this?
Sure.
Sure, okay. Uh, Let people know we're in typicality. Oh, okay. So don't make this harder than it is. Again, with most of our math, now the challenge at the end of the term is that you have so many things in your brain. Can you keep them organized? What we're doing doesn't actually seem hard anymore once it's set up right. So just put all of them over 22 and actually write it the right way. Don't write your fractions diagonal. You're not a website. 11 over 22, 2 over 22, and the total is just all 22. The relative frequency, you do top divided by bottom. So 5 divided by 22. I'm going to use my handheld calculator because it's easier than flipping around. So 0.2272. Right? And so on and so forth. 11 divided by 22, well, that's going to be half. 2 divided by 22, that's 0.0909 repeating. And 22 out of 22, that's just going to be all of it. Everyone okay here?
Yeah.
Yeah.
Flopping. So this is about 23%. You could make it 22.7 if you wanted. 0.5 is 50%. 0.09 is about 9%. You could make it 9.1 if you wanted. And 1 is 100%. Ta-da. Now is everyone ready to do this on homework if you had to?
Yeah.
Could we potentially do another one?
We do another one? Yes. Let me do that. Um, I don't know if I have one ready to do. Let me check real quick. I do here. Sure, this will work. So 200 college students were surveyed to find out how much they spent on textbooks that term. The results were rounded to the nearest $50 and whatever magazine did this. So we'll need our extra columns. So we have the frequency. This is the counted frequency. Then we might want as a fraction. Do you want a separate one for decimals and percents, or do you want to jump directly from fraction to percent?
Fraction to percent.
Directly to, okay. So that's called the relative frequency instead of the counted frequency. Sometimes counted is also called the raw frequency because it hasn't been processed yet, like raw food. Okay. Okay, sorry, I was doing something that was going to make a bingy noise. Okay, so as a fraction, we need the total. Do we know what the total is?
200.
200, it told us that. Whoops, not totally, just total. So that means all of our fractions are going to be out of 200. 8 over 200, 34 out of 200, 56 out of 200, 40 out of 200, 34 out of 200, 10 out of 200, 18 out of 200. Oh, my bingy happened anyway. Okay. And then top divided by bottom. So 8 out of 200 is 0.04. So we go right into percent. And get 4%. What's the next percentage going to be for 34?
17%.
Exactly. 56.
28.
Mhm. 40. Are you seeing the pattern? What's the difference between 8 and 4? Or 34 and 17?
It's half.
It's half. So we're doing a divided by 100 with the riplop. So all that's left is divided by 2, since we're dividing each of these by 200. So this is going to be 20%, another 17%, 5%, and 9%. And if somebody actually wanted to know the total, then that would be 100%, of course. Okay, happy there?
Yeah.
Yeah.
That was a lot of numbers. Did I write anything wrong? I think I'm good. Holler if I make mistakes. Okay. If you made a bar chart, then they would look quite similar. The only difference is that one of them has the counted frequency on the axis and the other has the percentages, the relative frequency. The bars would look quite similar, just if your scale was the same or not. Then we talked about a pie chart. Once we have the percentages, we could also find how many degrees of a circle that is. the whole circle all the way around is 360 degrees. So what's 4% of 360? What's 17% of 360? And so on. We could make another column. And that would tell us when we're drawing a pie chart how big to do things. So that's the little thing I stole aside over here. So someone had done that with the 4 tendencies data. Oops, move it on its own slide. Oh. So they had said 18% was the percentage we got for being a rebel. So they multiply that by 360 and got 65 degrees. So then they took that 65 degrees and they took a protractor and measured, and this was 65 degrees. So that's what they drew. And you could see there's eraser marks. Whoever did this had to fiddle a little to get everything nice. If you're not used to a protractor, I would love to have us all in the same room and I could hand out protractors and we could do this together, but now is not the right term for that, sadly. So you won't have to make any pie charts, but you deserve to know how. Pie charts are normally pretty miserable. There's almost nothing that a pie chart describes more clearly than a nice pretty bar chart. But sometimes they do. So one famous one is this one here. Somebody said a lot of investors, when they're saving for retirement or looking at their pension plans or something like that, think that if they have the S&P 500, they have an equal share of 500 different companies. But that's not true. These big tech companies, Apple, Amazon, Google, which is now Alphabet, Microsoft, and Facebook, are so much bigger than all the other major companies that they take up about half of what somebody would actually be holding as stock if they had an S&P 500 fund. So you're not very diverse. If you think your S&P 500 makes you safe if there's a good or bad year for industry or healthcare or things like that, then now you're actually putting half of your eggs in the basket called tech stocks, even if you don't realize it. Another interesting one was this one, where the circle in the middle is the electoral college vote, and the outside ring is the popular vote. So does the popular vote and electoral college vote match up? So these are all the different years from 1860 to 2012, and you can see how much it changes. But it's hard to find examples like this where the pie chart seems more meaningful than a bar chart that has the same information. Ready to move on?
Yes.
Yeah.
Okay. Once we have the relative frequency, we can use it in word problems. So no one really cares that there were 21 students that were counted that attended class that day. We care about 29% of other numbers, not that 6 students wanted cats that one particular morning. So maybe the term has 80 school days. If we have morning pet facts, how many of those 80 days should have cat facts? 29% of 80. Or there's 35 photos about pets on the wall. To make things seem fair to the students, how many of the 35 photos should be cats? It's going to be 29% of the 35. Here's one not about the pets. For a fundraiser, an elementary school class makes sugar, oh, it is, never mind, make sugar cookies, and they're using the cookie cutter to make cookies shaped like their pet. if there's 252 cookies, how many are shaped like dogs? So you'd have to say dogs are 19%. What's 19% of 252? So often the whole point of measuring the data is to use it in lots of different circumstances. The relative frequency matters a lot more than the counted frequency. Questions about that one?
I'm good.
You can see the answers if you want to know 29% times something, but that's kind of old math for us. Okay, then the last kind of tables, something that's new for today, are contingency tables. Contingency is how different effects overlap. So I'm just going to put this one on the Jamboard. It's easier to play with than talk about it. This is different than what we were just doing. The columns are no longer how many of things were counted. That's what the total is. But we have these subcategories. So we can ask questions that seem similar, but are actually a little different. And since this is brand new to everyone, I'm going to go very slow and careful. Okay, is my font too small on my questions I'm copying and pasting?
Looks good to me.
No.
No, I don't trust you. I'm going to make it a little bigger at least. Whoa, that's a lot bigger. One. Oh, I guess that's what it is. There we go. Okay. So we have 70 different students. That's our grand total of all these students who were asked, but they were asked two questions. One is, how much are you exercising? And there was 3 different responses. Are you exercising enough? Not at all. A little, and yes, I'm exercising enough. Besides those 3 responses to one question, they were asked another question with 2 responses. Are you homeschooling your kids because of COVID? So some of them were, and some of them weren't. So this total is broken up into 2 groups. Of the 26 that were not exercising, 16 of them were homeschooling and 10 of them were not. Everyone see how these kinds of tables work?
Yeah.
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 You've probably seen tables like this in real life. If not, then they're not that tricky. It is not always true that the totals are given to you. Sometimes these bottom row and rightmost column, you have to draw on yourself. But it's not hard to do. You would just add everything up. In this case, somebody is polite and the totals are there. And you can ask different kinds of questions about the overlap of these different issues with a contingency table. So first question, what percentage of the 70 students were homeschoolers? What is my part divided by whole for that?
Would you add all the homeschooling together?
Yeah.
And would it be 56?
So it's all homeschoolers. And then we're dividing by What's the whole amount?
70.
70, right? All students, my grand total.
Eight percent.
So how many homeschoolers were there? The total of that was 28. I don't have to re-add the 28 into these three.
Oh,
Does that make sense? All the homeschoolers were exercising not enough, a little, or yes, enough. So that's all of them right here.
oh,
It's been added up for us already. So 28 divided by 70 was what?
4%. 0.4.
No, that's almost half of 70. So 0.4 is going to be, oops,
4%.
not 4. So right into percent once, twice,
40%.
40%. Remember, if you go past the edge of the number, you have to sort of put a 0 for that second scoop. So 40% of the students were homeschoolers. They were in this homeschooling side of things. Now we're going to be trickier. So we still have a part divided by whole. What percentage were homeschoolers who were getting enough exercise? So first, let's just think about what's my whole in this situation. That's not the grand total anymore.
Would it be
28.
Yeah, it is only the homeschoolers. It's the 28. Everyone see why?
Yeah.
As it says, what percentage were homeschoolers? What percentage of the homeschoolers, right? That is our baseline for comparison. That is our whole amount. Then getting enough exercise. So this is a combination things. This is homeschooler and yes, enough exercise.
Is it 2?
It is 2. The ones that are in the homeschooling, this is sort of like playing Battleship now. The ones that are in the homeschooling column and the yes enough row, that's just those 2, nobody else. So 2 divided by 28 is about 0.07. So that would be 7%. So out of only the homeschoolers, 7% of them, 2 of them, were getting enough exercise. Everyone okay with how different that is?
Yeah.
Yes.
Yeah.
Oh, no, I just did it totally wrong. I am sorry. I am too convincing. I am evil. Let me move this out of the way. I answered the next one, not this one. That's terrible and embarrassing. So that was the what percentage of homeschoolers. Number 30 was supposed to be what percentage or what percentage. It's still the 2, the homeschoolers and getting enough exercise. But since we didn't actually say of homeschoolers, then the implication is that it's of all of them.
So
That-
70.
It would be the 70 there again. Does that make more sense? Because I was saying it wrong the first time. So now we get about 0.03, so 3%.
So because it says were, it means all of them.
Yeah, if it doesn't
No.
have an of something, then it's implied that it's all of them.
Okay.
But that is more an English language thing than a math thing, which is why it tricks me too. Okay, anyway, those are contingency tables. I'm sorry I messed up. That was not good the first time we did it in class, but you can be smarter than me. Or at least more awake. Or both. Okay, and that's pretty much all we need to do with picturing data. And last we have mean, median, and mode. Has everyone heard about mean, median, and mode? Shout out if you haven't.
I haven't.
You haven't. Okay.
Kind of have, but kind of haven't.
So only
Yes and no.
mode is only there because of tradition. For some reason, all these math textbooks had mean, median, and mode, and they just now have to because that's how it used to be. So if I say find the average of a group of numbers, you've known how to do this since elementary school. You add them up and divide by how many. That's not a problem. So let's get a random problem. Here's a problem from a different place. So there's 6 numbers. I'm going to add them all up. So 164 plus 134 plus 71 plus 6 plus 22 plus 29. And you might have done this faster than me. Let's see, 164. 426. Oops, pen is. Everyone get the same thing? That's not our answer though. What else do we need to do?
Divide by 6.
Yeah. Oh, I get 71. Ooh, that's one of them. Is your mean, is your average always going to be one of the numbers?
No.
No, that's just coincidence. And you can easily think of groups of numbers that don't, like the 2 numbers, 1 and 10. If you add them together, you get 11. 11 divided by 2 is 5.5. That's nice and in the middle, but it's not 1 and it's not 10. So let's talk about this a little more carefully. The mean is often what is used for everyday situations to talk about the average. It, in many real life situations, provides an answer close to what's more often, or close to what is most representative. It's trying to be inclusive of the data set. So here's a bunch of preschoolers. One of them weighs 34 pounds, 3 weigh 36, 2 weigh 37, and so on. We could find the mean, the average weight. So you'd add up all the numbers, and then there's 12 of them, so we'd divide by 12. Everyone happy with that?
Yes.
So same problem. The only trick here is there's 3 36s because of the height of that bar. And there's 2 37s. Okay. The mean is also where a teeter-totter balance scale would balance. If I have the numbers, let's actually do this one. I have two 2s, a 6, and a 10. If I was to put them on a balance scale, 2 plus 2 plus 6 plus 10, I'm getting ahead of myself again, is 20. There's 4 of them, so 20 divided by 4 is 5. That's our mean, that's our average. And does it look like 5 would balance on the scale? Yeah, that works. Our eyes are actually remarkably good at this. If you look at a histogram, we skipped over histograms, but the kinds of things that say like, here's the grades everyone gets on a test, we are very good at finding about what the mean would be, about where this balance is. Where would you think for the one on the board right now?
Would it be 73?
73. If I was to try and draw a balance with 73, I think it would look a little lopsided to the right. Let me put it on the Jamboard to show you. So if I said, let's make this be on a teeter-totter, $73, then that's kind of in the middle left to right, but there's a whole lot more weight over here. That's going to fall down on that side. Where should I put my balance point instead? You want the big one again?
Would it be between 85% and 86%?
Something like that. Yeah, we're not very good at eyeballing it precisely, but something more in this region. Does that now seem that that weight is going to balance out that weight?
I think it
Yeah.
would.
Yeah, that looks better. So there might be some disagreement as we're eyeballing this exactly where it is, but it's somewhere about here. And if we wanted, we could just add up all those scores, divide by how many, and really find out. Okay. There is a word you will need later in your career. It is on the GED, but it's officially level 9, not 9, level D. Sorry. And but we'll talk about it anyway. And it's standard deviation. Deviation isn't like funky, risque stuff. It's just deviation, meaning how far it moves away. And the standard that it's moving away from is the mean, the thing in the middle. So if I have these 4 charts, then the first one, A, does it have a lot or a little of this deviation? So our mean is going to be right in the middle. Things are pretty symmetrical, right? Something around here is more or less my mean. Are things close to the mean?
Not really.
Not really. There's a fair amount of standard deviation, right? Most values somewhat far from the mean. So that's kind of medium amount of deviation from the standard, of standard deviation. Make sense so far?
Yeah.
How about B? Is B more or less deviation from the standard?
Less.
So comparing it to this one. How much are they compared to before? It's still true there really aren't any close to the standard, close to the mean. Can you see how they're more apart? They're more away.
Yeah.
This one is high standard deviation with green. Which chart has the lowest standard deviation?
C.
C. They're not exactly on the mean, but they're close to it. There's not as much distance apart. If I have C, then if I go just a little way out, I'm including most of them. This is a low deviation from the standard, a low standard deviation. So we are not going to talk about it any more than that. Just know that it measures sort of clumpiness. A low standard deviation means it clumps together nicely on the average. A high standard deviation means it's kind of allergic to the average. It's avoiding it. Some data might be like D. It's just kind of all over the place. It has a kind of medium plus standard deviation just because it's kind of no pattern at all. Later on, you'll learn how to actually put a number to standard deviation, but for now, we're just going to do that. Okay, the next thing we have is the median. Oops. This will be our last real math topic, and it's all review. And the median happens because there's a situation with some things that are terribly not typical. So remember that preschool classroom. Now, 3 of the preschoolers say, we love our stuffed animals. They weigh 1 pound and 1 pound and 2 pounds. If we try and do what we did before and take our preschooler chart, then this is going to be terrible. We're going to say that there's a 1 and a 2. 2 things weigh 1 pound. 1 thing weighs 2 pounds. If we add up all these numbers and divide, we're going to get something in the middle over here as our mean. Does that make sense?
Yeah.
And that's not realistic for anybody. It's a lot more than the stuffed animals. It's a lot less than the preschoolers. So if you're trying to in some way represent what's going on in this room, having an answer that's something like 20 doesn't make any sense at all. So we'll do the median instead. And the median is a process that seems like almost it's not math. So, but it is. So we have We're going to take all of our numbers and we're going to write them in sorted order. So when we sort them, the first ones are the 1, and the 2 for the stuffed animals. And then we have to put these in order. Are the kids in order already? Yes, somebody was nice to us. Then once I have put everything in order from least to greatest, I'm going to pick the middle number of the list. So let's just kind of count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Keep going. Keep going. Aha, here's the middle number of the list. So our median is 37 pounds. And if we look at our terrible chart, then that makes sense. That actually seems to be representative of the kids somehow. Everyone okay with my yellow example?
Yes.
Okay, here is a question. If we changed 41 to 999, would the median change?
No.
No.
No, it's just something we're skipping over. So what kind of real life situations, more practical than trying to weigh stuffed animals along with kids, when would you want a median? What is that useful for? Any ideas?
Figuring out which one of your kids is the middle child.
Yeah, but probably you know that already. What are kinds of data sets in real life where there might be one number that's way too big or way too small, and we're just going to ignore that number? Okay, I will share. So,
I was going to say a couple things.
oh, okay, well, share your things then.
Like your salaries, if you're purchasing a property.
Yep, house values. So if there's a big neighborhood with 30 houses and one family builds a nice addition and their house gets bigger, then that probably doesn't change everyone else's housing price a lot. Right? They are now the nicest house in the neighborhood, but it's really not typical of the neighborhood. The other housing prices wouldn't have it. Or salaries, if we're working at McDonald's and everyone makes a small amount and the manager makes a big amount, then if you're saying what's a typical salary at that McDonald's, I guess McDonald's is hourly, but you know what I'm trying to say, then you're going to skip over the CEO or the manager and so on. So salaries, incomes, house values, things like that. The mode is the number that appears most often. If there's a tie, all the ties are modes. So who wins the vote? But math doesn't really care just about what's the most popular thing. So we never use mode in a math class, but there we go. So what we had before was finding the mean of 6 numbers. We added them up and divided by how many. Let's find the median of them also. So the smallest one was 6 in our list, and then 22, 29, 71, 134. We're going to run into a slight trickiness that we didn't see before. So we go in 3, we go in 3. Both of these seem to be equally central, right? There's 2 on the left, there's 2 on the right. What do we do if there's 2 that seem to be both middle-ish? We don't have to invent it. It tells us. If there's an even number of values in the list, there won't be a single middle one. So we find the mean of the ones that are most in the middle. So we'll take these 2, add them up, divide by 2, always 2, because there's always going to be 2 that are middlemost. And whatever that is, 29, 64.5. Oops, no. I forgot my parentheses. Don't be like me. 50. Okay. Ah, I caught my own mistake. Okay, and that's all of mean, median, and mode. One of them you add them up and divide by how many. The other you pick the middle of the list, or if there's a tie for middle, add them up and divide by 2. Know if that interests you. Back to recording. So that is all we need. There is more in this typicality section about bell curves and probability, but none of that is level C. So all of that is stuff we could talk about if you want, reinforce our percentages and other things we've talked about, but only if you care. It can wait.
I care.
Does anybody want to do more of what we did today that was new with picturing data or averages? Should we look at 10 exercises for averages, even though you don't have to do them?
I would, please.
So find the mean of 6 numbers and the median of them, add them up and divide by how many, or sort them and find the middle. Here is how many books different children read. Can you find the mean of this chart? So different from a chart than just when you have a list of numbers. And then the median also. Once you have the numbers off the chart, put them in order. Home values on a street are this many in thousands. So 384,000, 364,000, and so on. What's the mean of those? And then what's the median? And for this particular street, which seems the most representative number? Freight containers, there's 7 containers, they weigh this many tons. What's the mean and median? And then a problem about which one represents things better. Number 9 is kind of interesting. There are news articles that will make a big deal when countries have an average temperature increase above the global average. So like here's a couple. Right? Alaska warming twice as fast as global average. Canada warming twice as fast as global. So why is that not surprising once we understand averages? And then a really weird one with the Writers Guild of America, there was a 2007 strike. And there's a mean and median there. Do you want to work on these now? Do you want to try them at home and we'll work on them Thursday? You don't have to turn them in, but I'm happy to give you credit and check off when you do. Oh, that was my other announcement. Time out. When I go to achievements, I don't have any achievements for that you've done presentations in class, like some of you have. I need some cute little meme thing to make so that like when you click on it, I have things to click on and so on. So if you can think of memes about making presentations in class, especially in a math class, then let me know. Okay, I'm gonna mute myself because my kids are about to come in the house and be noisy. And you can tell me what you want to do, whether it's this or something else.
I'd like to work on the 10 exercises.
So if we haven't done the justice measurements, are we going to also do the 2 typicality ones, or like the entire typicality things as the homework as well?
I don't care if you do the typicality homework. This stuff is sort of end of level C. If a level C class gets to it, great. I'm glad you know it. It will help you on the GED a lot. But if I don't measure you on it, that's okay. If we leave it off the final, that's okay. What was the thing that happened before Joel spoke? I'm sorry, it was noisy right then.
I was just saying I'd like to work on the 10 exercises.
Work on these?
Yeah.
Okay, let's do that. You want me to change the numbers or give away your homework?
Either way.
Either way works for me.
You know, okay, well, if we go down to the random ones, then the first 2 can change easy. Oh, that one has a 1 on it. That's yeah. Okay, you work on these 2 while my kids are noisy. I'm gonna get my little one organized in the shower and come right back. Okay, I'm back. So what was the sum in problem A of those 6 numbers?
I got 264.
Everyone else get 264?
Yes.
I got,
Then we'll take that and divide it by 6 because there's 6 of them. And
44.
44. Okay. Then for B, what was the order you put things in?
Five.
Five. 5.
12, 17, 37, 76, and 117.
So the middle two are going to be the 17 and 37. So 17 plus 37 is going to be 30, 40, 54. And 54 divided by 2 is going to be 27. Ta-da! If you want to change your mind and put these on the final, we can. They're easy. Okay. Bar chart. So we need to change this chart into a list of numbers. How many books should students read? So what do I put for Mary?
2.
2. Anne is
4.
4, another 4, another 4. Tom
3.
is 3, Jerry is 0. We have to keep him in there. Why do we care that Jerry was 0? Does a 0 matter when we add them up and divide by how many? Yes, Jerry is one of these people. Whether we divide by with Jerry or without Jerry, we get a different number. And what goes in the middle, if we put something over here, that shifts the middle a little bit. So his 0 matters. Okay, anyway, enough about Jerry. Dan is 2, 3, 4. Everyone okay with my list of numbers?
Yeah.
Yeah.
Yes.
Okay, what's the sum?
$30.
I got the same thing.
Okay, I'm also getting 30. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the mean is going to be 30 divided by 12. $2.5. Everyone knows the famous joke about the average American family has 2.5 children or something like that. No one read 2.5 books, at least on this chart. It's okay if the mean is not any of these numbers. Okay, the median, we need to resort all of these. So we have the 0, and I like to just kind of cross them out to show we're done with them. We have 2 1s. 1, 2, 3, 3 2s. Oops, I'm, as always, thinking about the next thing. 2 3s, 2 3s. And 4 4s. Okay, there's all my things. So what's the middle? 1, 2, 3, 4, 5.
2 and 3.
1, 2, 3, 4, 5. I need to go another step. So these ones are the middle. So halfway between 2 and 3 is going to be 2.5. So in this case, the mean and the median are the same. That shouldn't be too surprising. They won't always match up, but for this data, there's not somebody that read 400 books. Jerry is a little below at 0, but it's not like he's drastically off the scale. So this isn't like Bill Gates moves into our neighborhood and makes a mansion and the property values have to ignore him. All of these are pretty similar to each other. So yeah, the mean and the median matched. I wouldn't bet money on it happening, but in this case it did. It's almost 8. We haven't done any break. Should we just talk about 9 and 10 and then be done for today?
Yeah.
Okay, try 4 we did. Try 5, 6, 7, and 8 on your own. We'll talk about them Tuesday. So sometimes Russia has global warming above average, or has its warming above global average. Well, it's a slow load page. Norway or Finland, are you faster? There we go, nearly double. Faster, right? So why is that not surprising? I will give you a hint. Remember this stuff?
Yeah.
So is it surprising that some things are more than average and some things are less than average? More than average, less than average. Even this one that's sort of just all over the place. So in any data set, unless all the numbers are the same, that would be a very boring group of numbers. If we have a bunch of different numbers, then there's going to be, oops, sort of a mean number about in the middle, what looks like it balances on the teeter-totter. And some are higher and some are lower. And some might be a lot higher and some might be a lot lower. So the fact that sometimes there are countries with higher or lower temperatures, even double or rate of changes of temperatures. No, if your change is double normal, that's okay. If I list a bunch of changes, some of them are going to be bigger than others. Some of them are going to be half of others. It's not surprising. That's just how groups of numbers work. How about number 10? There was a Writers Guild of America strike, and according to CNBC, in 2006, there were 4,434 writers that worked full-time. And their average salary, if we just say average, is that mean or median?
Mean.
Mean, right? Add them up and divide by how many? Was big, $204,000. Why would those people go on strike? They make lots of money. The LA Times, just a few days later, said the median income for all the writers in the guild was $5,000 a year. Those people are almost broke. Sure, go on strike. You need more money. So why is there such a big difference? And don't peek at the paragraph for the answer. Any guesses? So first, now I'll show you that paragraph. The headlines leave out two important facts. First, almost half of the guild writers don't write anything in a given year. They're part of the guild, but they have other jobs. That's what they're doing. So if we are listing out all of their incomes, half of them are going to be zero. Then of the others, a very few writers write the next Hollywood blockbuster and earn millions of dollars. So you'll have something like 500s. They just wrote a little bit of something, and some thousands, and some 5,000s. Maybe a 10,000, and then 5 million. So this first one was saying, of the ones who worked full time, that would just be these, or maybe even just those, or maybe even just those, then their average salary was big. When you add up these numbers and divide by how many, this giant number means you'll get something big because the add them up part is so big. Everyone okay with that part?
Yeah.
Yes.
And then this one said, if you really made the list correctly, which I didn't, my zeros, there's too many of them because I could fit more on the page, right? But if you made the list the right way, then half of them would be zeros. So by the time you get to the middle, then you're getting something like 5,000. I didn't do this quite right, because I have all these zeros over here to balance out the millionaires and the other high earners over there. So my list is wrong, but hopefully it is at least close enough that you can see how both of these things could be true. The moral of the story is when people are talking about what's typical, pay attention. Are they using means or medians? Because you can obviously paint very different pictures of a story depending on which type of average you use. Okay, any last questions about finals or classes or anything? If you want me to turn off recording, I will.
I can't think of anything.
So if you haven't done the justice fractions and percentages and measurement, please do that. If you want to, you could try the 10 exercises for prisms and patterns. That's good stuff for the GED. But I'd rather you are very solid on the other stuff rather than butter your toast too thin. And if you're quite ambitious, you could even do the ones for averages. We've done most of them already anyway. And for each of the topics, then try their test at the bottom. A few problems at a time. Don't bite off too much for your brain to chew on. And the ones to pay the most attention to is the ones at the bottom of justice that says the overview for all of them. When I see you next time, ask me homework questions if you have them, or we can also talk about overview questions if you've done that. Between now and Thursday, hopefully you have time to at least try a few of these a few times. Maybe you'll try 1, 2, and 3 and struggle with something and then go, oh yeah, it's been a few weeks, but now I got it. And you'll be able to report on Thursday, I can do the first few, great. Or maybe there's something that's just slipped your mind because it has been a few weeks and we'll go back and review it. If anyone wants to pick something to present, either from the playgrounds or health or personal finance or business, then feel free to either you present it or to say, instructor, I want you to talk about this because I'm interested in that. Again, you are here more than just for the GED. Maybe you're going into retail. Maybe you have kids and want to use math games to teach them stuff that they're learning. Maybe you're planning a wedding or buying a house or any of these other things. You can put some of yourself into class and see how math helps you make real life decisions and review the stuff we've done. Anything else before I say goodbye?
I'm good.
I think I'm good too. Thank you.
Okay. Have a good 2 days, not a lot of time, but if you can put some time into math, then we can get more out of it Thursday.
All righty. Have a good night.
You too.
Thank you. Good night.